Year 6. It's such a shame that you can't come and see us and be with us for your transition and your integration into the school. But we're still really excited about starting the science curriculum with you, and I thought it would be really nice for you to be able to see some of the things that we might have been doing had you been able to come and see us this term. So my name is Mrs. Pettican, you might have seen me from the video, and I'm the Head of Science. And today I want to talk to you a little bit about some parties I like to throw. Now obviously as a scientist, the coolest accessory any science person can wear at any party is their safety goggles. We also recommend these as a pretty cool accessory when you're in and around the science classroom. Problem is, I've got a big team in science, and when I invite them over, I, as you would for any party, like to get them a drink, and we all have a drink of water. But that didn't go down very well my first party, so I thought to myself, well, I can get them some juice, that might be quite nice, but they all like different flavours. So I found myself this magic juice. It's fantastic. A small amount placed into water gives great results. So for example, Mrs. Stoko, she loves apple juice. So getting her some apple juice is not a problem. But Miss Cleesby, when Miss Cleesby comes around, she always asks for strawberry juice. Not a problem, now I've got this. And Mr. Peacock, well, he's quite troublesome. He often asks for blueberry and blackcurrant. But fortunately, I can see to that too. Of course, my learning leaders aren't the only people who come to my parties. Sometimes we have even more. So then I've got to get really creative. If I add some of my strawberry juice, and very carefully, a small amount at a time, add the blueberry juice. One, it's becoming a little fizzy, but I can also create some nice mango juice. Now obviously science is magic to me, but the real part is actually the fact that I'm sure you've guessed this isn't really water. These are chemicals. Now these chemicals are, hiding away, hydrochloric acid, got some sodium hydrogen carbonate, and some sodium hydroxide, and this is a chemical called universal indicator. These are all chemicals that you'll use in science, and they all have different pHs, and we use this to be able to tell the range of pHs. Lots of things have different pHs, even things at home. So you could go home tonight, and if you asked a grown-up to have a look in their cleaning cupboard, most of the things in there will have a pH on it, because even toothpaste, lemon juice, all of the things in our household, shampoo, they all have different pHs. So this is one of the experiments you might be doing.
Okay, hello Year 6, and welcome to this Practical Science Showdown today. I am Mrs. Collins, and I'm a teaching technician, and I'm also head of STEM Club. So in school we run an after-school extracurricular STEM club where you get to do lots of fun activities in science, technology, engineering and maths. And you're going to gain new knowledge, you will develop independent learning skills, and you'll gain an insight into all the fantastic and exciting job opportunities that there are out there. Okay, so what I'd like to do this afternoon is just introduce some fun little activities which you might like to try at home afterwards as well. Okay, so the first one is a bottle volcano. Okay, so what you're going to need for this, if you try it out, is some bicarbonate of soda, or otherwise known as baking soda, some red food colouring, approximately 200 ml of white vinegar, a little water, and some dishwashing liquid. Okay, so the first step to do is to mix your 200 ml of vinegar with a little water. Okay, put in a nice squidge of colouring. Give it a stir. And finally, a nice blob of dishwasher liquid. Okay. We're then going to add this to our small pot bottle. Okay, so you could use whatever size bottle you wanted, but if you used a bigger bottle, you would probably need to adjust the quantity of mixture and use a little bit more. Okay, so that's going to sit in there. Okay, and then for the next step, we're going to add a bit of water to half a cup of baking soda. We're just going to top that up. So we've got roughly 1/4 of a cup all together of baking soda mixture, and I'm just going to put that into my beaker so it's easier to pour into the bottle. Okay. And I'm going to see what happens. So perhaps some of you have experienced this one before, so you might hazard a guess as to what's going to happen. But if I pour my mixture in, whoa, explosion time, okay. So that was reminiscent of a volcano, whoosh, okay. But why did it do that? Okay, so as you know, we started with vinegar, some coloured vinegar, and we added the dishwashing liquid, which made it nice and foamy. Okay, but the reason it jumped out of the bottle in the way it did was because when we mix baking soda with vinegar, we have a chemical reaction taking place, and we know, because we're scientists, okay, that if we mix bicarbonate of soda with an acid, which is vinegar, then we're going to get, among other things, carbon dioxide gas. Okay, so that carbon dioxide gas got produced really, really quickly, and that's what caused it to fire out of the neck of the bottle. Okay, so that's a really good one. You could try at home to impress your friends and family. Okay, and the next one I have for you, now this does involve warm water. Okay, so you do have to be careful, and I do recommend that you have an adult about if you try this. Okay, now I have two, in each case, a pair of glass flasks, but you could use any glasses or jars you have at home that were similar. Now what we've got is, to indicate cold water, we have blue. Okay, so we've coloured the cold water blue, okay, and we're colouring the hot water from the kettle red. So all we've got in these glass vessels at the moment, okay, is water of different temperatures, okay, so red being hot and blue being cold. Okay, so what I'm going to do first of all is I'm going to show you what it will be like. Okay, so we're going to sit our cold water on top of our warm water, and if I take this plate away, what you should see happening is the colours starting to mix, okay, and eventually we'll end up with a paler orange, okay. And what's happening there is the warm water, you may already know that warm air rises, okay, and in a similar fashion the warm water is trying to reach as high as it possibly can up this tube, and as a consequence